This video is on how to put OpenSense Firewall in as a firewall solution into Azure, and we're just going to go through getting it running, accessing resources behind it, and then using an OpenVPN tunnel to talk to those resources behind the firewall as well. So to get started, we want to create a Hyper-V VM locally, and that's going to be so that we can configure a VHD disk and put that into Azure after we configure it. So when creating these things, I like to put them in their own directory so that I don't have files everywhere. Now at the moment we don't have what we need. We need a special connection so that we can connect to the OpenSense firewall on its default IP address. So we're just going to leave that unconfigured at the moment, and we're also going to create a new hard disk as well with different settings than the defaults. So to do that, we just want to go new hard disk, and we want to create a VHD, not a VHDX. We want a fixed sized hard disk. We want to put it beside our, and it's probably good to call it, and we don't want it to be 127 gig because that would make an expensive VM to keep running, and we just hit finish. So that's going to take a few minutes, so I'll pause the video. Now the virtual hard disk is almost completed, so we can now go into our settings and attach it, and we also need to put an ISO file for our installation boot disk, which is the OpnSense DVD version of the AMD 64 ISO. Now, just before we start this, we also need to create a virtual switch internal switch here, because we want to be able to connect to our VM. So if we go into settings now, it's saying it's not connected, so we need to connect it to this switch, and we'll just start up our VM. And as we do that, as the VM starts, don't put any user input in, otherwise it stops booting up to the login prompt. Well, that's what I found. So what we're looking for in network connections is the virtual Ethernet interface that we just created on that switch, and we just need to give it a 192.168 192.168.1 and it could be anything other than 1, because the booted OpenSense instance is 192.168.1.1. So we're just waiting for that to continue to boot. And as soon as it boots up, we can then start the installer. Okay, so we just enter the word installer at the login, and then OPNSense, and just go through and select the defaults is fine. Okay, install it to the virtual disk and say yes. Now once you see the progress indicator, that means you're a few minutes away from completing the install, so we'll just pause the video to wait for it to complete. So installation is completed. You can set the root password here in the wizard, installation wizard, or you can do it via the GUI, but we'll just pop out the DVD drive and then exit and reboot, and then wait a minute or so for it to reboot. So we're now ready to connect with a browser to our local OpnSense instance. So HTTP 168.1.1, and it redirects us to HTTPS. Type in root and OPNSense, and now we get an initial configuration wizard, and we can just leave most of the defaults unless you feel like changing them. And let's change the root password. So there's no default password when we load the image to Azure. Now the next steps are absolutely vital, otherwise you won't be able to connect to your OpnSense instance via the WAN interface. So what we need to do with that is go to our interfaces. So we've got LAN is already enabled, but we need to enable the WAN interface and just save that and apply the changes. Now once that's been applied, we can then go into the firewall rules and go to the WAN interface and just see that there's no custom rules yet. We're just going to create one, and we're going to use just an alias. So I'm going to call that web config. It's going to be for ports, and we might specify any number of ports that we connect. Say we want to access the firewall on port 22 by SSH. 443 would be the normal port for web config, but we're going to move that to 60443 so that it doesn't collide with things we might want to publish, such as a 443 website. So we're going to now hit save for that and go to our rules and our WAN, add a new rule and say anything that hits the WAN interface, inbound, TCP, and its destination, could be any, or we could just explicitly say the WAN address, but we want to then say you can connect to those config ports. You can log the packets, and that's handy, so you can see people trying to connect to your ports. So allow web config, and that's now given us it's basically an anti-lockout rule, but it's a manually one we create ourselves. Now once that's created, we need to do some other configuration, which is go into settings. I think it might be administration, and we're going to change to 60443, so the TCP port. We're also going to disable redirects, because we don't want people just naturally to find if they hit port 80 on our firewall. We also want to disable some security features while we get set up within Azure. Now we could enable secure shell, nothing wrong with that as long as you lock it down to only being accessible from trusted IPs, but we're just going to leave that. Another crucial setting is the console needs to be changed to serial console, the primary console, because we need to be able to access that within the Azure portal. So once all that is done, we hit save, and then it will prompt us to redirect to a different port number. And if we've got that right, it will just pop us to there. So now we can shut down our virtual machine, which we're configuring here locally, and the next step is to upload it to, or upload the VHD file to Azure. Now to do that, we've got a Azure tenant here that's completely bare and blank. So the first thing we need to do is just start with creating a storage account to hold that VHD. And spelled it wrong before. Alright, now southeast is Melbourne, so we do that. If we want to save a bit of cost, you can just reduce the redundancy there. Generally it's okay to leave the defaults. Now, once this storage account deploys, we want to connect to it using Azure Storage Explorer. So I've already downloaded and configured this to connect to my tenant, and then once that's fully deployed, so it still hasn't said yes I'm okay, we can then go in and create a blob container. So create a container and we can just call it OPNSense, and we just want to go and find the VHD. Now this is a problem that you really need to be aware of. This has got a snapshot, this has got a, they call it checkpoints in Hyper-V, but this is wrong. So basically you've got your base disk here and then you've got a checkpoint here, so this is going to cause issues. So what we need to do is collapse these two into the one file. Now to do that, just going to close this, and then we're going to right mouse button and choose settings, and go OK. And right at the moment, if we have a look, we need to delete that checkpoint. So what that will appear as is when we again go to upload the file, we'll know that it's deleted by, so it's still there, and that might take a little while to fold itself back into the main VHD file. But if you've got that, you're not going to successfully upload your image. Right, so you can see it's just disappeared there now, so now we can select the VHD and just choose the upload option. Now depending on your transfer speed, it can take a while. So I'm just going to pause the video while it uploads 16 gigabyte image. So our upload of the VHD is completed to Azure. So what we're now going to do is just have a look at our storage account and we look in the storage browser, blob containers, and we can see that we've got our VHD there. But the next step is to create a virtual network to hold, as our image shows, we've got to hold our virtual machines and subnet them into a front-end subnet which is going to face the internet, and a back-end subnet which is going to hold our production VMs. So to do that, we hit the virtual networks icon and just choose to create a virtual network, and we add that to the same location, the same region that we put our VHD in as well. Security, just leave those the same. Now it's a good idea when we create a virtual network to choose something that's not in a normal range, a commodity home Wi-Fi router would use. So generally what I'll do is just change the IP address of the virtual network to be, the address range to be something a bit different. And then once we do that, we can also just modify, we're going to call this the front end, and we don't need 256 addresses, so we just reduce that down to something a bit smaller. And that's our front end subnet. Let's add another subnet, and we'll call this one the back end. And this one is not really requiring direct internet access, so we're going to configure that. So I'm just going to call it a private subnet, and we'll just leave that at 256 addresses. And then once that's done, we just hit review and create, and hit create, and it will deploy. Now our next step is we now need to deploy our OpnSense disk image. So first thing we need to do is create that disk image from the uploaded VHD. So we hit create in the disks area, and then we just call it, and we say okay, source type storage, and then we go and find it. Now absolutely vital is that you select either Linux or Windows, obviously Linux in this case because it's a free BSD, I think it is. So if you select none, you won't have a bootable VM, you won't be able to create a VM from this image. So standard security, I don't know if this is required, but you can also reduce to standard SSD, which reduces performance but also reduces cost as well. So once that's done, just have a look, and we can step through and ultimately we hit create to create our managed disk, which we can then convert into a virtual machine. Let's go to that, and because we've set it's a Linux disk, it gives us the option to create a virtual machine from it. So here we go, OPNSense, OpenSense. Alright, so no other, so yeah, 1 gig of memory, that's okay. We'll leave the disks alone, but we want to put this into the front end network. So, and we also want a public IP address, and that's enough for that screen. Now let's go through management, monitoring. It's nice to have boot diagnostics so you can see a picture of the boot screen, and we hit create, and then we hit create again. Now, as that VM comes up, we're going to have to add to it a network interface card for the back end. So we can do that while it's starting up. So again, so we can go and it's saying to create a new virtual network. We don't want to do that. We want to put it into the back end, and it's just an IP version 4. Now looking at the network here, we can say, okay, I'm going to assign an IP address, make it static as well, and then from there I think we just need to hit create once it validates. So as that deploys, we can go back to our virtual machine, which is now probably running, but in order to make changes we need to stop it so that it will be in a deallocated state. So we stop our OpnSense virtual machine, and as that stops it goes through deallocating and then to stopped deallocated, and then we're ready to make the tweaks we need to add a second NIC to it. So once it says stop deallocated, then we can go in and make some changes. Now, because this is a firewall and the network security group is generally out in front in the way, just going to create a rule that basically is an any rule that says, okay, I will allow any traffic through, and that will then, we don't need our SSH rule at all. So that's just basically allowing everything to the front end interface of that firewall. Now the next thing we want to do is attach the NIC that we created for the back end, and as that attaches, we just need to give some thought to what else we might want to do. One of the things that we can do while things are going on is give it a DNS name. So we can click on a DNS name and we can go OPNS, and hopefully just click save once we've done that. So our public IP address will now be addressable by this, probably it's a very long host name, but that will give us the ability to talk to the firewall with a host name. Now we're getting close to wanting to start back up again, but we do need to make some changes here. First thing we want to do is we'll just say that our front-end NIC has a static private IP address. And once that's done, we go back and then we select, we need to, haven't done that yet, hasn't, maybe just need to, thought it had already done it, but it hasn't. Let me have a look here. Attach network interface. Okay, so sometimes you don't see what you expect to see. Alright, maybe we can go away from this screen for a moment. We definitely created, let's have a look at our network interfaces. We definitely created it and attached it, it's just not showing up. So sometimes that can happen. Nope. That's really interesting. So potentially, let's have a look what's caused that. Let's go back to our network interfaces. And it's in the back end, but it doesn't seem. Okay, so we do need, now that I'm here, we do need to make another change to this backend NIC. We need to enable IP forwarding, because if we don't, then if we look at our image, these hosts at the back here won't be able to forward their traffic through. So that's vital. Enabling IP forwarding is critical for this this backend NIC. And let's just have a look at the properties. So I'm not sure, but we're just going to go back to our virtual machine here. And so it's certainly gone missing. It's saying it's attached, but for some unknown reason, there it is, it's finally showed up. Alright, so that is now connected, and we've also checked the front. Let's just double check. This has got our allow any, so we're ready to now boot this up. So let's click on start, and if we want to watch the boot sequence, go to Serial Console underneath help, and because we've made the Serial Console the primary console, this will nicely connect, and we can see it as it starts up, which is helpful, and that can then give us the ability to interact with it as if we were in front of it. Now before we do that, let's have a look at our network interfaces again, because we do want to have a look at the properties. Now our backend NIC, we're just going to create some, so I'm going to say backend, the MAC address is that, the front end is, let's have a look here, so the front end NIC is that, so let's see it's slightly different. So that's needed so that we can successfully configure the interfaces. So going back into the VM, back down to Serial Console. Now, in theory, it should have already booted up now, so it's just getting close. And we've got our login prompt. So we can now enter login as root, and the password we changed it to. And at the moment, you can see that the LAN interface is still got a fixed IP. We don't see the WAN interface, so that's now our job is to assign our interfaces. Don't need link aggregation, no. Don't need VLANs, but we want to now identify our, so 58 is HN0 and C8 is HN1. So our WAN interface is this one, and our LAN interface is this one. So what we want to do is we want to say the WAN interface is HN0 and HN1. And we don't need to enter the optional interface, so we're just going to let it do it itself. Do you want to proceed? Yes. So now we have our interfaces assigned, and we see one's already picked up a DHCP address, but we might now set the interface IP address for the LAN interface and configure IP for address interface with DHCP. Yes, please. Configure via WAN tracking. No, we don't want IP6. I'm going to just disable it and then enter for none. No, I don't want to change things to non-encrypted. Do you want to generate a new certificate? No, I don't. Restore the defaults. We'll just leave them the way they are. So now it's saying, okay, you can connect to the LAN IP, but we don't have access to the LAN IP. We only have access to the WAN because the LAN is behind and we've got no access to that. So what we need to do is find out what the IP address of the public IP address is. So we can grab that and let's see if it's, yep, we'll just pop it in here. And we don't want to halt it. Let's just connect and see how we go. And it's worked immediately, which is good. And now, saw me type a password then. Fortunately, it's not any of my ones I've used before. So, alright, so now we've got logged into our interface and we just want to make some changes so that it's correct regarding the DNS name. So we'll just put this into our settings. So we go System, Settings. I think it might be Administration is the first place we'll look. We're just going to go into General, and we're going to add the host name and the domain name. Now you would normally give yourself a custom domain name, but we're just going to use the one that we get from Azure. So save that, and then we notice up here that the name changes. What else can we do? We can go into Administration and we can turn off. Now we don't want HTTP to redirect to this high port. We want it to be a bit more hidden than that. We can turn off this disable DNS rebinding check, and we can turn off this now that we have a properly set host name, and save. Now it's saying that it's redirecting, but what we're going to do as well is now access it using the host name, so that alright, so the next thing we can look at is the interfaces of our firewall. If we look at the overview here, we can see that we've got the WAN interface has a private IP of this, and the LAN interface has got the private IP of this one in the .1 subnet. Now, what we now want to do is use the LAN interface as the gateway for all the computers that we might be putting into the backend subnet. So let's go and create a root table that will make that a reality. So click Create, and we certainly don't want it in East US, so we'll just go root table 1 and create the root table. Now once that's created, we then need to create a root or route if you're American, and that route is going to say, and we'll call it the default route for the back end. So we go IP addresses, and we're saying to any IP address, the next hop will be the LAN interface of the OpnSense router. And that is good and that's correct, but if you forget to do the following step, then nothing happens. So just remember, always go to the subnets and associate it with the correct subnet. So what you want to do is select the virtual network and the subnet, so the backend subnet, and then just associate it. And so that will now successfully, any client in the backend subnet will route through the OpnSense server. Now to give ourselves a client, let's create another virtual machine, and this one is going to be a Ubuntu box, and we're not going to use public key, we're just going to use the insecure password. Alright, and go next, next. Now this is going into the back end, so that's correct. We don't need a public IP address, and we can leave most of the settings, I believe, as their defaults. So as this virtual machine boots up and deploys, what we want to do is we want to think about how we're going to access it, because it's behind the OpnSense firewall. Now, the first thing we're going to do is do a port forward to SSH to this virtual machine, and then we're going to publish a website or even a web server, and then finally we're going to create a OpenVPN server on the OpnSense box to get remote access to the subnet behind the OpnSense firewall. Alright, so that's nearly up, it's coming up, it's up, and let's have a look at its private IP address. So that's our private IP. So this is, if we have a look at the serial console, this is our Ubuntu box, and it's got already got an SSH server running on it. And if we just log in, we can see it's, yeah, so we can see we've got the SSH running on it. What we'll do, we'll just install a web server for something to talk to as well. And now in OpnSense we're going to do some port forwarding. So we're going to do a NAT port forward, and we're going to create a rule that will forward. So whenever any traffic hits, and we're not going to do the standard SSH port, we could, but what we're going to do is whenever anything hits this high port, so, and we could change this to be advanced and really restrict it to a safe IP, but we're not going to do that. We're just going to leave it as any for the time being. But whenever it hits the WAN address on this high port, redirect it to the Ubuntu VM back to SSH, and then we can say port forward. Alright, and you might want to log the packets as well. Right, so has that worked out? Now the crucial thing is always to remember to hit the apply button. I don't know how many times I've made that mistake. So what we're going to do is we're going to SSH. We can use either the IP or the, hopefully, so that's not going to work, is it? Because I need to specify that high port 60022, and we can see that our port forward has worked, and okay, so we are now logging in over the internet through the OpnSense firewall using a port forward. Now we'd also like to publish our HTTP, so whenever it hits the WAN address of the router, the firewall, and it hits HTTP, we also want it to, I've forgotten, what was the IP address? It's 10. So we want to go there, and this is a straight through one. We're not actually so in theory we can now connect directly to the Nginx instance in that backend subnet. Okay, so this is where we need to remember to apply our changes. And there we have it. So that's port forwarding back to a web server or to the SSH on a different port. Now what we want to do is look at how do we remote access using a VPN to our Azure backend network. And to do that, what we want to do is start with the system trust authorities. So we want to create a certification authority, so a certificate authority, create an internal, and we're just going to call this OpenVPN CA. Now all these settings, there's lots of different tutorials in YouTube regarding this, so I'm just going to leave everything the same as what you'd see in the documentation on the OpnSense site, with a few local modifications here. But so yeah, so we don't need to necessarily fill all those things out, but we can if we want. So we've got the OpenVPN CA. Notice it's self-signed, so it's the root it's just signed by itself. But the next thing we need to do is create a server certificate, and the vital thing is it has to be signed by the CA. So we go OpenVPN server certificate, and this obviously is a server certificate, and then we just set it to the settings recommended by the help documents on the OpnSense site, and that's done. Now we could, I did remember from the help documents that the description, or yeah, they had a common name, and I think I probably would have done something a little bit wrong, because in the help documents, when you add it, it's something like the common name is, they say to do OpenVPN internal CA or something similar to that, but I don't think it matters, but we're just going to move on. Now the certificate for the server has to be signed by the OpenVPN certificate authority, otherwise you run into problems. Now the next thing we want to do is we want to create a user account and username, and you can do all sorts of complex password for the user, and you can leave a lot of these things as their defaults, but the critical thing is to create a user certificate. So hit save once you're ready, and this one's called, we'll make that the same name as the username. It's a client certificate, should be matching what we've already selected, has to be signed by the CA, otherwise it won't work when you try to log in, and we can leave most things as their defaults there. And so we've now created a user certificate signed by the CA. Now the next thing we want to do is actually create our OpenVPN server instance, and the server instance, so we just call it OpenVPN Remote, let's call it Remote Access Server. You might have site-to-site servers as well using OpenVPN, so it's good to be explicit. We know it's local database we're going to authenticate off. Now we can leave pretty much everything the same, but we probably don't want to publish the VPN server on the internal interface. We just set it to WAN. TLS authentication, let's make it both, authentication and encryption. We definitely want to make sure that the certificate authority is right, so select the OpenVPN CA one. The server certificate again has to be correct, and it has to be signed by the OpenVPN CA. Encryption algorithm, we can make that AES 256 CBC, and then we scroll until we find SHA-512, and pretty much that's everything. Now the IP version for tunnel network is something that's not going to be colliding with your subnets. So if we have a look at our virtual network and our subnets, it can't be anything that's in this address space. So what we can do is to the tunnel network, we can just make it something like, just say 50.10.24. That's our tunnel network. Now the local network is the back-end network. So if we have a look here, we've got our back-end network. So 10.45.1.0 this is the, if we have a look at our image, this is this area here. So that the Ubuntu server has 1.5, and we want to just make that that's the networks local to the OpnSense server. So don't redirect the gateway unless you want all your remote clients to use your firewall as their internet gateway. It's probably nicer just to have the traffic that's only the traffic needed. Right, and then from the documentation, the only thing I think that they change that I could tell was this renegotiate time. So that's everything that I believe is necessary to get our server properly configured. Now, something that I forget to do is then to make firewall rules that allow the traffic. So let's go and check to make sure that firstly we need the LAN clients, so IP version 4, anything on that backend LAN needs to be allowed, so that's there and it's okay. On the WAN side, we need to make sure that we can connect to the OpenVPN server. So we just say WAN in IP version 4, UDP, source any, destination could be any as well, but we want to change this to OpenVPN, so 1194, that UDP port, and you might want to log the packets for people connecting to your VPN server just to see if there's exploits going on. Allow VPN clients. So once that's done, we can see once we return to our listing there, so we've got out that allow rule, so that's going to allow remote connections, but we also need to go to the OpenVPN interface and make an allowance for the server network. So we'll just go over and grab that. So we'll go to OpenVPN server, and the tunnel network is what I meant to say. So 10.50.10, we want to make sure that is enabled and allowed on the OpenVPN interface. So we hit the plus sign again, we say pass OpenVPN in, any is okay, but the source is a network, and that's the 24 network. So anything from our VPN clients will be allowed to go through the OpenVPN interface. So we hit save on that, and this is crucial. Always remember to apply your changes. And now we've got, I believe, everything we need to get a client connected. So to get a client configuration, just go to VPN, OpenVPN client export, and we're going to use OpenVPN Connect as the software to connect, and just do a web search for that and you'll find the download. And to get it working, we want to specify not a private IP for the host name. We want to specify whatever domain name or IP address that we're going to publish as. We want to hand out just a file. We want it to be file only. And then once we've just selected that, we can then download our OVPN file. Now, if you open an OVPN file with Visual Studio Code or an editor, you find that you've got firstly the certificate authority certificate, then you have the user certificate along with the user's private key, and then finally the TLS certificate that enables authentication and encryption for the TLS connection. That's what I believe it does. And then a whole bunch of OpenVPN settings, that many of which we've entered into the OpnSense server. Now to view those certificates, you can go into System, Trust, Certificates, and if you want to have a look at, there's your certificate for your user, or you can download the private key and the certificate as well, and you can see that those certificates are, if you just basically, you can see that they're in the OVPN file. The authority has again that ability. You can download the certificate or the private key from the CA, and again it's the same file as in our OVPN file. So that's just helpful, because every now and then you might find you're wondering why, and you might want to examine the certificates to find out if something's amiss with why it's not authenticating. Now, once this is done, you can then do the import of that OVPN file. So it's in downloads, so I can just do that and then type in the username. We can choose to save the password, and then finally let's see if it works when we hit connect. Now it's worked, which is always a good thing. So this is our Ubuntu box in the cloud, which we're connected to via port forwarding, but we want to see if we can ping it from our local workstation. Let's see if that works, and it works. Now let's see if we can ping the internal interface of the OpnSense server, and again that works. We can also just see what, so we can see that we've got internal access to our box via the VPN. And so what that means is you now have the ability to deploy any number of hosts into a backend network, connect to them or port forward to them as you need to. Really, once you've got OpenSense or pfSense or any of those firewall solutions, you can then start to create site-to-site VPNs in a number of different platforms, and then you've really got the ability to protect your network, or just get a test network up and running fairly easily. So I hope this has been helpful to someone.